Dear students, welcome to NEET Direct Day 16, Gravitation Day 2, PYQ Assignment Solutions. So let us start with question first. Acceleration to gravity at a height 1 kilometer above the earth यानी at a height h वाला फॉर्मूला लगाएं इसमें. ठीक है, ये है फॉर्मूला height h वाला. ओके, इट इज सेम एज एट अ डेप्थ d यानी g डेप्थ वाला फॉर्मूला लगाएं विच इज दिस फॉर्मूला. और कहा गया इट्स सेम, ये दोनों इक्वल होने चाहिए यानी जी एच एंड जी डी शुड बी इक्वल. दैट मीन्स जी टाइम्स 1 माइनस 2h बाई आर शुड बी इक्वल टू g times 1 minus d by r. Alright. Now simplify. This gets cancelled here. This gets cancelled. So you have 2h by r equal to d by r. These two get cancelled. Alright. हमें पूछा गया था d का value. You have to find value of d. So here d is twice of h. And what is height given here? 1 kilometer. So you can put 1. So answer is 2 kilometers. So you can see that this option is D. So D is the correct answer to question first. Now let's move on to question second. A body weighs this much, 200 newtons on the surface of the earth. How much will it weigh halfway down to the center of the earth? यानी आपको डेप्थ वाला फॉर्मूला ही यूज करना है यहाँ पे. This is a formula. Multiplying with m on both sides. That means on the surface of the earth, this is the weight. On the surface of the earth, this is the weight at depth d. Your formula. Now you put on the values. This w is 200. Okay. 1 minus half the way down to the center of the earth. यानी r by 2. D का value r by 2 as per the statement of the question. Now you simplify. This gets cancelled. 200 into 1 minus 1 by 2. That is half of it. That is 100 Newton. This is the answer to this question, and 100 Newton means your answer is option C. Now let's move on to question third. With what velocity should a particle be projected so that its height becomes equal to the radius of the earth? यानी height उसका radius of earth के बराबर हो जाना चाहिए. This question can be solved on the basis of law of conservation of energy. That is, change in kinetic energy is equal to change in potential energy. And here I mean gravitational potential energy. Because when the particle reaches the highest position, its velocity becomes 0. So change in kinetic energy is simply half mv square minus 0. Because finally the velocity will be 0. Alright. And as far as the potential energy is concerned, initial potential energy by the standard formula is G M M by R. All right. Now this is initial, but we have to do final minus initial. Final is this G M M by 2R. Why so? Just because here we have height equal to R plus R, that is 2R. That's the reason why I chose to write 2R here. This is a final value. All right. Okay. Now you can simplify it half mv square, and on this side this minus and minus has become plus. So we can write it like this: G mm by R 1 minus 1 by 2. And this overall value is now like this. Now you simplify. And by simplification, I mean strike off what is common on both sides. 2 and 2 goes away. This m and m goes off. And therefore, v square becomes gm by r. Hence, v is equal to gm by r square root. This is the answer. That means if this, with this velocity, a projectile is projected upwards, the particle is thrown upwards, with this initial velocity, it will acquire height equal to the radius of the earth. Now, let's check out which option is it. This is option A. Okay, now let's move on to question fourth. You have to find the change in gravitational potential energy when a body of mass m is raised to height nr above the surface of the earth, where r is the radius of the earth. In simple words, if originally the particle is here where r is the radius of the earth, now it has to be shifted far away, where the height is now r plus nr, because this is r plus nr. So this is the whole height, r plus nr. In this process, how much change in gravitational potential energy has taken place? This is what we are supposed to determine. Okay, let's use the formula gmm 1 by r1 minus 1 by r2, right? This is a standard formula. Now, change in potential energy means gmm, small m is the mass of the object that is being raised, all right? 1 by r1 means simply initial position, that is capital R, minus r2, which is the final position, which means r plus nr. Let us further simplify this. This gmm, you take the LCM, r time r plus nr, and simplify this, all right? And as you can see, these two get cancelled away. I move this r here in the next step. Now my step next incorporates r here, and over there in the numerator is nr, in the denominator you have r, take it common, 1 plus n, right? Then simplify this entire equation. This now becomes gmm by r, as I write, it is n upon 1 plus n. What if I multiply with r and divide with r? That is, I have done additional r there and there. How will this help me? This particular quantity is small g. Now you have this m, you have this n, you have this r, and remaining is 1 upon 1 plus n. Let's now simplify this. How? You have m g r written over here, and the remaining term is n divided by 1 plus n. This is the change in potential energy of that particle. Now let's cross check. We have this option A. So A is the answer to this problem. Now let's move on to the question 5th. Particle of mass m is situated at the center of a spherical shell of radius a. This is spherical shell of radius a, right? And there's a particle of mass m. This shell also has a mass m as per the question. Now you have to find what is the potential at this location, which is lying at a distance a by 2 from the center. The concept is very simple and clear. You have to find potential at the distance a by 2. That means you have to find change of potential. Change of potential means initial potential minus final potential. Initially particle is lying at the center, and the surface of the sphere is at a distance a from here. So it is gmm by a. And since now in the second step you have to find at a distance a by 2, you have to write minus g m by a by 2. All right, you simply are adding up these two. That is, you have to find potential initial, potential final, add them up. Both potentials are negative as per the definition. Gravitational potential is negative for attractive force like gravitation. So the two minuses remain as they are. Gmm by a minus 2 gm by a. It becomes 3 gm by a with a negative sign. So this is the answer to this problem. So as you can see, this means option A is the correct option for this question. Now let's move on to question 6. Escape velocity of body on the surface of earth is this much. This is standard value, all right. Now if earth's mass increases to twice the present, यानी earth का mass बाद में twice the present value हो जाएगा. Radius becomes half. That is, final radius will be half of present value of the radius. Then what will be the escape velocity? Well, to simplify such a question, you first will have to find the value of g. As per the standard formula, g is given by this, and g prime is the changed value. That will be like this. Take the ratio of these two equations. This is there, and now put in these values which are given here. Make these substitutions. यानी m की जगह पे आप लिखेंगे 2m, r प्राइम में लिखेंगे r by 2 whole square. It is r square by m. Now start simplifying. This r square cancels out, this m cancels out, and what you have now? 2 into 2 square, which is 8. So g prime is 8g. Now this is a core expression. This will be used later in our calculation of escape velocity. As you know, escape velocity is given by this formula, but this can be condensed to this formula. All right. And similarly, we can write formula for escape velocity in this situation as just mentioned. Take the ratio. VE prime by VE is 2G prime R prime by 2GR. You can simplify this. This and this gets cancelled. Now G prime as written is 8 times G. So I write 8 times G. Radius of Earth has become half. So I write R by 2. Down under is G into R. You keep on simplifying it. This and this cancels. 2 4s are 8. This square root of 4. This 2. So VE prime by V is 2. VE prime is twice VE. VE is given to us 11.2 kilometer per second. So you have now 22.4 kilometer per second as the answer to this problem. So as you can see, option to this problem is A. All right. Okay, now let's move on to question 7. Escape velocity from Earth's surface is V. Okay, this is V. Escape velocity from the surface of another planet having its radius 4 times that of Earth. Okay, radius is 4 times that of Earth, and same mass density, that is rho prime and rho are same. You have to find the escape velocity for that planet. Well, as you know, the formula for escape velocity is given by this is standard expression which involves the value of the radius and the density of a planet with escape velocity expression. Now over here, escape velocity of Earth is proportional to r into square root of rho. For the other planet, the radius has become 4r, but density is same. Now take a ratio. All right, so planet and Earth का escape velocity 4r rho square root r square root rho